Okay, I'm back. I'm on page 229 at the bottom. And, I kind of assume you're just watching these videos in order, but I feel compelled to tell you where I am anyway. Um, all right, so this problem is we want to find to three decimal places where the line through 1, 2, 3 and negative 4, 5, 12 intersects the sphere x squared plus y squared plus quantity z minus 4 squared equals 50. So I'm going to write the equation of the line, and then I'm going to jump over onto the calculator and then do it, and then I'm probably going to jump over to GeoGebra and then graph everything and see if it's actually working the way that we think it is. So for the line, I'm going to need a vector, right? So maybe I'll put the line over here. So it's going to be, so I need my vector. All right, so negative 4 minus 1, negative 5, 5 minus 2 is 3, and 12 minus 3 is 9. All right, so that's my vector. And now I'm going to write the equation of the line. I'm going to use parametrics because that is the best form of the line. Okay. X equals, Y equals, Z equals. I'm going to use the point 1, 2, 3. I think anyone is crazy if they use the other one. Like, why would you do that? Negative 4, 5, 12, that's what you want to deal with? All right, minus 5t, and then plus 3t, and then plus 9t. T is an element of the reals, so that we can, go every which way in space. And so now I'm going over to, I'm going over to the calculator so that I can try to solve this system, right? So what I'm going to do is I'm going to take these values. So I'm going to take these values and I'm going to sub them in here, turn that into a function of t, then it's going to be a quadratic. I'm going to solve the quadratic and then take the t values that I get and take them and plug them back into the line, and that should give me the intersection point. So that's kind of the path that you follow. It's like parameterize the line, take the line, sub it into the thing. It could be a sphere, it could be a plane, it could be like any random surface that you're given, sub it in, solve for t, take t that you get, go back to the line, plug it in, you'll know. So it's like the circle of solving. So I need to open up calculator, and then I need to share the calculator with you. Let's see. Here we go. There's the calculator, hopefully. So I want to, what do I want to do? I'm just going to kind of like type it in. So 1 minus 5, you know what I'll do? I'm going to do this. I'm going to do x of t colon equals 1 minus 5t, y of t colon equals 2 plus 3t, and z of t colon equals 3 plus 9t. So now I have parametrics there. There's a bird outside my window that is very distracting. It's like making a branch go crazy. All right, I'm going to take these and sub them in. So I'm going to do that in sort of a weird way. I'm just going to type in, oh, I'm not going to do that in a weird way. All right, ready? Quantity x of t squared plus quantity y of t squared. So do I need to put x of t in parentheses? I don't. I could have just done x of t and then, x parenthesis t close parenthesis, and then I could square that. I think it's safer to do this though because you're like sure of what you're squaring. Quantity plus quantity. Now at this point you might be yelling at the screen, you forgot solve, and I did. So I'm gonna have to fix that. Equals 50. I'm just gonna press enter and see what happens. It's gonna I think expand everything, and we'll see the quadratic that we're facing. Okay, that's our quadratic. So if I can solve this, do menu 3, 1. I want to solve that equation for t. Get those answers. Okay, so what should I write down? I'm gonna write down. Let me go back to the iPad here. How am I gonna do this? I have so many things I need to look at and also share and whatever. All right, I'm going back to the iPad. That's my problem, not your problem. So let's see. All right, so I feel like I should write a system, right? So I'm gonna say x of t squared, I'm going to put that in parentheses, plus y of t squared plus quantity, oh, I don't need that one, okay, z of t minus 4 squared equals 50. And then I'm just going to write down what t was. So t is, it says 3 decimals, and let us do that. So I'm not going to share it. I'm just going to go back to the calculator and get 3 decimals here. So I'm pressing Control Enter instead. So t is approximately negative 0.553. Whoa, where are you going? 553, where t is approximately 0.692. 0.692. Okay, so these are the values that I've gotten for t. Now what I'm going to do is I'm going to take those t values, I'm going to sub them in for x, y, and z. I'm going to sub them into x, y, and z. So I'm probably going to go back to the calculator. So I'm going to actually go back and share the calculator again. I thought I was going to get away with not doing that, but I think I'm going to have to. Okay, so I'm back here. One thing I did, though, was I stored my functions, right? So I can do var of t, comma, y. No, not y. What am I doing here? I'm trying to demonstrate the var key, and instead I'm just typing y of t. So the advantage, one of the advantages of var key is that it shows you everything. And also, if it's a function, it like opens parentheses for you, kind of saves you almost no time, but some time. All right, such that t equals, I'm just gonna paste this. Too many t equals. I'm gonna delete this. Go. Okay, I'm gonna write that in the notes right now. You just do that also and stare at the screen while I'm doing that. Running out of space. Running out of space in these notes. All right, so let's see. If this is it, then man, would I be proud if you showed me notes that look like the notes that I'm writing? I don't know. 764 0.341. So always 3 decimals. The reason we're doing that is next year you might be taking AP Calculus. And if you're taking AP Calculus, every numerical answer that you write down that's a decimal should be to 3 or more decimal places. So I always go to 3, correctly rounded. Get in the habit of that. It's like muscle memory, right? And if you get in the habit, you won't screw it up. So that's why I always say 3 decimals. There's a method to the madness. All right, and then I'm plugging in the other one. So you can't see that, but I'm going to write it down now. It's probably really a weird video at this point. I got negative 2.460. I'm going to write the 0, not necessary, but I'm going to write it anyway. 4.7, nope, 4 point, is this even project, what am I on? Oh, that's right, I'm crazy. I forgot what I'm supposed to be projecting, and I was freaking out. I was like, oh my God, this video is long, I'm gonna have to do it all over again. 0.76, comma, oh man, no room here. I'm gonna switch colors. You can't even see it though, so I don't know why I care. 9.22, it's what you do when people aren't looking that matters, right? So I should still kind of care. 9.228. Okay. Let me go back to the notes so you can see the mess that I made of these. And share, and share, and share. I'm getting pretty good at this swapping thing. Okay, so you can see I indicated which point goes with which t value. And now what I'm going to do is I'm going to go to GeoGebra and I'm going to graph all this and just see what happens. So if you're not in it for that, you can dump out of the video here and I will see you in the next one. Otherwise, hang around and we're going to do this. So I think you should hang around. I mean, you know, analysis is like an experience. And we do a lot of things that like you don't need to do, but you should want to do them. So I'm going to graph the sphere, x squared plus y squared plus z minus 4 squared equals 50. So that's big. I'm going to zoom out so that it's like, there. All right, so now what I'll do is I'm going to plot the line that we wrote. So I'm going to use curve for that. So curve 1 minus 5t, comma 2 plus 3t, comma 3 plus 9t, comma t, comma, I don't know. So I know the t values that I need are negative 0.5, like negative 0.6 and like 0.7. So I'm going to go negative 1 to 1. And it should like, work. So I get this. Okay, so what I can do is instead of trying to like type these in, I'm going to do a. So it named the curve a, so that's why I'm doing a, and it's a function. Like I can do a of 5, and it'll like put a point at wherever it should be at 5. So I'm going to do a of, my first value was negative 0.553. This is like the moment of truth, right? So did it get what we wanted? And then also I want to do a of 0.692. And we get that. And now what we need to do is like move it around so we can see if it worked. And it looks to me like we totally got it. All right. So I would definitely like to encourage you to try to do everything on GeoGebra. If it's in 3D, GeoGebra can probably do it. You might just have to think about how to do it, but thinking about how to do it is how you learn. So like, it's an obvious thing that you should try to do. So if you have any time, break it out, go to the website, and I think you will learn a lot by doing that. So I'm going to end this here and come back, obviously, with more of the notes, and I will see you then.